This video is for section 13-6, geometric series. A geometric series refers to the sum of the terms in a geometric progression. A series is just like a sequence, but the commas are replaced with adding signs. Like with an arithmetic series, where we came up with a formula to find the sum, let's do that again for a geometric series. So if you write out the terms of a geometric series, it would look like this. If you then multiply each member in this equation by negative r, it creates this equation. Then if we add the left sides together and add the right sides together, it results in this equation. Then to get the letter s alone, which was representing sum, we would divide by the 1 minus r on both sides. And that creates our sum formula for a geometric series. We had a different sum formula for an arithmetic series. Let's use that formula to do this example. Find the sum of 8 terms of a geometric series where the first term is 1 and the common ratio is 2. So we want to find the sum of 8 terms. We're going to put an 8 for n. The letter A is the first term. We're told that that's 1 minus, and then we have the letter A again. So 1. And then times r, we're told that r is 2. Raised to the n power. We're using an 8 for n. And that's divided by 1 minus r. Again, the ratio is 2. We need to simplify this. So we have 1 take away 2 to the 8th power, all divided by negative 1. At this point, you could use a calculator to get this answer. In the numerator, 1 minus 2 to the 8th power is negative 255. And then when you divide by negative 1, the answer is 255. If you wrote out 8 numbers where the first number is 1, and you multiply by 2 to get each number, you would have 1, 2, 4, 8, 16, 32, 64, 128, and then added those numbers up, it would be 255. The point is that the formula gets us that answer faster than actually listing out all the numbers and adding them up by hand. This formula involves knowing the first term and knowing the value of r. It's also helpful to have a formula where you know the first term and the last term. And that's given right here. So just like with an arithmetic series where we had 2 different formulas we could use, there are 2 different formulas for a geometric series. Here's an example. Find the sum of a geometric series whose first term is 4, last term is 324, and common ratio is 3. In this example, we know the first term and the last term. So let's use the sum formula that used that information. If we scroll back just a little bit, we can see it. A minus r times a sub n divided by 1 minus r. And we'll make our substitutions. The variable a represents the first term, that's 4. The letter r is the ratio, that's 3. A sub n represents the last term, that's 324. And then we have 1 minus 3. Now use a calculator to evaluate that. 4 minus 3 times 324 is negative 968, and then divide by negative 2. That makes 484. Here's one more example. Some key information about a geometric series is given. Find the unknown information. So we have the letter n, we have r, and we have the sum of n terms. We want to find a, and we want to find a sub n. Well, let's use a formula that has the letter a in it. That could be our first formula from today. S sub n equals a minus ar to the n divided by 1 minus r. Then make substitutions. For s sub n, we have 121 over 81. We don't know the value of a. For the letter R, we have 1/3. And for N, we have 5. In the denominator, we have 1 take away 1/3. Now we need to simplify this until we can figure out the answer for A. So 121 over 81 equals A minus, and then let's do 1/3 to the 5th power, which gets times by A. That makes 1 over 243 times A. And the denominator is 2/3. Next step, we can multiply both sides by 2/3 because that will get rid of the dividing by 2/3. So on a calculator, 121 over 81 multiplied by 2/3 makes 242 over 243. And that's equal to A minus 1 over 243A. When you combine like terms on those A terms, it makes 242 out of 243A. In this equation, we can see that A is equal to 1. And so we found the answer for A. Now we can find A sub n. Let's use the other sum formula, the one that has A sub n in it. It was S sub n equals A minus R times A sub n all over 1 minus R. For S sub n, we can fill in 121 over 81. Now that we know the letter A, we can fill it in. 1. R is 1/3, and A sub n we don't know. And the denominator is 1 minus 1/3. Let's do some simplifying work on this. We have 121 over 81 equals 1 minus 1/3 times A sub n all over 2/3. Like last time, we can multiply by 2/3 on both sides to get rid of the dividing by 2/3. So this is 242 over 243 equals 1 minus 1/3 A sub n. Now subtract 1 from both sides to get rid of this 1 right here. That makes negative 1 over 243. And that's equal to negative 1/3 times A sub n. Finally, we can multiply by negative 3, because that's the reciprocal of the negative 1/3, and that will cancel it, getting the A sub n alone. So that makes 3 over 243 is equal to A sub n. 243 does divide evenly by 3, so we can reduce this fraction. It is 1 over 81. So now we've discovered that other number we were looking for. A sub n is 1 over 81. We were able to find the two unknown numbers by using our sum formulas. But we had to do it twice because first we had to find the value of A, and then once we knew that, we could get the answer for A sub n. Let's summarize the lesson. We looked at formulas for how to find the sum of a geometric series. There are two of them. One of the formulas uses the value of A, R, and the last term. The other formula uses the value of A, R, and the number of terms that you're adding up.